And now we're going to get deep into the hackathon. And here with me to explain everything, get in the ins and outs for the first time, being solely a digital hackathon, is Markus Kleinfercher. Markus works in the innovation management at Infineon, responsible for the coordination of the Infineon Hub at the Vienna University of Technology and participation in the Infineon Startup Cooperation Program. Welcome, Markus. Stage is yours.
Hi to everybody. Thank you for the kind introduction. With this, I want to welcome you to the official start of the Virtual Infineon Hackathon, powered by EIT Manufacturing. As said, my name is Markus Kleinfercher. I work for Infineon in the Department of Innovation Management, and I'm going to be leading you through this opening ceremony today. Before we start, I want to thank our Deputy CTO, Mr. Stefan Rohringer, for his kind introduction in the past hour or half hour, speaking about startup cooperation at Infineon and how important it is to us and the innovative landscape. And I think with being part of the Vienna Up 2021, we as Infineon are very eager to further strengthen collaborative innovation within Europe and globally. And I think starting with today, the Virtual Infineon Hackathon with participants from India to Germany, from Greece to Austria, we are on a good way to do so. We've been looking forward to this day for quite a while now, and I'm very excited for seeing innovative ideas blossom within the next 48 hours of this hackathon. And speaking of innovative ideas, at this point, I would direct the word to our main sponsor of Infineon, Mr. Günther Wellensohn. He is also at the Innovation Management at Infineon Villach, but unfortunately he cannot be with us here tonight. Therefore, one of my dearest colleagues, Mr. Raphael Gattringer, will be giving insights into Infineon and the Infineon Hackathon. And he's a very important part of the innovation management at Infineon, and he's also a very, very big and important part of this hackathon. So, Raphael, whenever you're ready, the stage is yours.
Yes, hello. My name is Raphael Gattringer. I'm here at the Infineon Hub in Vienna. So this is usually the hub where Markus has his headquarters, but as is in the studio today, I have the pleasure to be here at TU Wien. This is very important to us that we are near students, of electronics, chemistry, and many other possibilities. Our headquarters is actually located in Villach, so this is a possibility to be also situated in Vienna. And I'm very happy today to be here, as this is part of Vienna Up, this hackathon, and we from Infineon decided to organize a hackathon to contribute to Vienna Up. For sure, under circumstances that are not easy in these pandemic times, but we're from innovation management and we are responsible for organizing new stuff, trying out new approaches, and so we're here today. And Markus, any questions at the beginning?
Yeah, maybe you could talk about a little bit of Infineon and the Infineon Hackathon and how it's structured and what will be coming up in the next 48 hours of hacking with all our participants.
First of all, a few words to Austria. Why Austria? In Vienna, we have a small sales office, which is, however, also responsible for South and Southeastern Europe. Linz, we have an R&D facility like in Graz, Linz for radar, Graz, for example, for security chips, and also automotive, like Markus is here from our team, who is a representative of Graz. Klagenfurt, we have IT, and our headquarters is in Villach, for sure, with over 3,000 employees. And we invest 500 million euros per year in R&D. So this is for sure a very important part, and you already heard a lot from Stefan Rohringer. This is a picture of our fab in Villach, which had a lot of investment, 1.6 billion euros in the last time. And this is our smart growth strategy. And I just want to talk about this because this shows you the birth of our hackathon, where it comes from. And it for sure comes from innovation. It comes from an R&D ecosystem. And we want to be open to the maker community and the startup community and open our walls, so to say, and provide all the people who want to work with our hardware with the latest hardware and the best hardware. What is a hackathon for everyone who's listening here now and might have never been to a hackathon? So we often talk about a problem-focused event. You have a challenge, a certain goal, and you try to organize as much as you can in, for example, 24 hours, 48 hours, or like larger events like Industry Meets Makers, perhaps half a year. And the goal is a prototype. So it's not the finished product, but a kind of POC or MVP that you can start working in that direction or just show that something is possible. And we often see that with startups, for example, that they use our hardware in ways we didn't know already. We also see, especially at hackathons, that people work together that usually don't work together. Like here it says graphic designers, interface designers. And this is also nice to see how collaboration is done. And this is a birth of innovation because people talk perhaps together that might have never talked in the future. And yeah, collaborate in a short period of time. And then we also try to support our hackathon teams when they are finished with further hardware, for example. We also try to innovate the format of the hackathon. So we not only hope that our teams provide innovative prototypes types, but also for sure the first hackathon in a pandemic. Last year we didn't have a large hackathon. But this year we said we want to try it and we want to try this online hackathon. And we are very happy we have 10 teams who applied and we still have slots free. So if you're a last minute participant, please use the registration form on our website and feel free to join. We have 4 large tracks with different topics, which is also an expansion of the offer we have. We have participants from Serbia and India, so welcome from all of these countries. We really try to make it work to include you as well. And we're the first time offering also Cypress hardware, Cypress semiconductor company we merged with last year. And for sure, new cooperation partners like EIT Manufacturing, COC East. Thank you, by the way, for this great cooperation. The MCI Innsbruck and also TU Wien. And I'm also happy that PMD Technologies is also sponsoring a prize for the 3D track. Really a short introduction to the agenda, which will be more details communicated later. But if you're like watching the hackathon in a general audience, interesting could be for you, for example, on Wednesday, the hackathon pitching. It's at 2 o'clock in the afternoon, and you can join again with the EIT live stream, as well as the award ceremony, which might be interesting for you. And also great thanks to our cooperation partners who helped us in promoting this hackathon. We had a lot of help, so thank you so much. And I'm happy for the next event and hope that we can collaborate again. Finally, I also want to talk about the maker page. We have a maker page, infineon.com/maker, where you can get all the information with certain maker boards. For example, on the right-hand side, you have your microphones on a Shield2Go board. And these are boards that you can easily connect to other systems like a Raspberry Pi, for example. And we also have a new maker guide, which was published right now. And you can also download it from our maker page. So this concludes my introduction. As Markus already said, Our greetings from Günter Wellenzorn, Head of Innovation in Austria. He's one of the, so to say, sponsors in management who really supported the hackathons from day one in March 2019 when we had our first large hackathon in Graz. And now the journey continues, and the first time with an online hackathon.
Well, thank you so much for all the insights, Raphael. And of course, thank you for all the effort that you put in to organizing this hackathon. I know it hasn't been easy the last few months, so a big thanks on this side. As you've heard Raphael explaining, the hackathon is built up of 4 tracks. Each individual track is a sound, 3D, biosensing, and circuit design. Therefore, up next, we will have all the people from Infineon who are responsible for those tracks, and we will be having them explaining the technologies regarding their individual challenges. So first up, we have sound, the sound track, as we like to call it, with Julian Eder. He's a system engineer at Infineon. And Julian, whenever you're ready, the stage is yours. Here you go.
Hi, thank you. So am I audible?
Yes, we can hear you.
Perfect. So thank you very much for the introduction. So pretty simple. I do not have a big presentation to share. I just want to share this GitHub repository with you. This is basically the starting point for our hackathon sound challenge. The idea of the challenge is, so you all already received a hardware package, including our Infineon Shield2Go microphone, our silicon microphone, and a Raspberry Pi. So the challenge is when you combine the Shield2Go and the Raspberry Pi as a system to do basic audio processing tasks with it. Based on this, implement machine learning applications, so come up with own ideas, what you can do regarding sound and machine learning. So the track is very open. There is no specific direction. It's just combining our microphone and the Raspberry Pi to set up machine learning applications to work with machine learning topics. And the technical background here is Python and this scikit-learn library. That would be one option to do it. Also, we have an example for Edge Impulse, but you can, of course, also, if you know the topic very well and you want to try something else, you want to do it on your own, you can, of course, do this as well. But if you want to use our getting started examples, you can open this GitHub repository and click here on getting started. Then you see that this is compatible with Raspberry Pi 4, which we sent you. Scroll down a bit and see how you can assemble everything we sent you, how you can get started on the software side. And here on the side, you can then find examples, for example, here, machine learning with Python and audio. And that would be how you could get started with this track. So I would say now, this is everything from my side for now. If you have any questions regarding the track, you can always contact me. I'm available in the forum and also directly via email or however you want to contact me. Thank you.
All right. Thank you very much, Julian, for presenting your track. This is the track with sound design. So next track is 3D, where we are going to have Mr. Markus Hennecke. He's Director of Innovation and Funding at Infineon, and Mr. Sebastian Schlund. He's a professor at the Institute of Management Science at the Technical University of Vienna. So gentlemen, whenever you're ready, the stage is yours.
Okay, thank you very much for the nice introduction. Yes, this track is about 3D imaging. So what does that mean? Well, 3D imaging is a method of perceiving the environment in 3 dimensions. Why do we need this? Well, we are in the manufacturing business here. We are dealing with robots. And you know that robots typically are encased in a cage for security reasons so that they don't accidentally hurt anyone. However, we want to move beyond that. We actually want humans to be able to interact with robots. Robots can be quite strong. They can hurt people. And so this is really only possible if robots can perceive the environment and see where people are so that they can interact in detail and can, for example, grab a piece from your hand without squeezing your fingers. So what we need are robots that can perceive the environment with high detail. And this is where 3D cameras come in really handy. So what does a 3D camera do? I hope that this video is coming across well. Basically, what we see here is a scene that a camera has recorded. The camera itself does not move. The camera is actually static. So the camera takes a depth image. What you see here is not a thermal image. No, the colors here encode the distance. So red parts are rather close. Blue parts are farther away. And everything in between, well, bright blue is not quite so far away. Green is somewhere in the middle. Yellow is somewhat closer. Orange, red. So the colors here encode the distance. And the brightness encodes the reflectivity of the materials. So if we go through this a little bit, what we saw before here is called a depth map. The same scene can also be represented as a point cloud. If you have a point cloud, the advantage is that you can turn it. So you can look at the table from underneath, for example. Or you can turn around and look at it from the side. So you have real 3D information. And all of that is provided by a 3D camera, such as displayed here on the left. By the way, this camera, the Pico Monster, is the prize sponsored by PMD for the 3D track. Cameras like that have been in use for quite some time. So the smartphones from Lenovo, for example, have had them since almost 5 years. We've also equipped virtual reality glasses with such sensors so that they can take an image of your hand and you can actually point at stuff in the virtual environment. They're also used in the car for in-cabin sensing, for example, for gesture recognition. The advantage here is that they can be made really, really small. Compare here with the head of a match. And that, of course, enables many other applications. Most of you know the Apple iPhone with the face authentication. This also employs a 3D camera, also 3D scanning, augmented reality, virtual reality, in-cabin sensing. And there are also smart robotic vacuum cleaners that already operate with sensors like that. Now, for this track, well, we have a virtual hackathon. So how do you set a task with a robotic arm in a virtual setting? You cannot actually send out robot arms. You can also not operate an arm remotely because you never know whether you actually hit something or damage something. So together with the Technical University of Vienna, we decided to work with a virtual robot arm. And the nice thing is that the TU Vienna has, within a different project, implemented something called assembly, which provides a robot simulator that can be accessed via the web, where you can use a script language, a little bit like Scratch, to program this arm. The code for this is also open source, so everybody can access it on GitHub, which in turn means that if you write any code, then you can also provide it there and continue to use the code after the hackathon, which is really cool. Because if you have a really cool idea, a nice project, then you can continue working on even after the hackathon. The task here at hand is to make this robot arm aware of its environment by implementing a 3D imaging simulator. So the first task is to implement a simulator that simulates such a 3D imager that can be placed, for example, on the arm itself, or that can be placed above the arm, looking down and checking to see if there are any objects. And of course, the next task is, if you have such an imager, what would you do it? What would you do with it? So come up with new use cases. What could a robot arm do if it can sense the environment like that? And with that, I would like to introduce the next speaker, Mr. Professor Schlund from the Technical University of Vienna, who can tell you a little bit more about their involvement.
Thank you very much. I just want to to tell you a little bit about our motivation to participate within this hackathon. Actually, that's here you see how perhaps the future of assembly systems might look like with a human worker there who's actually doing an assembly task for an aircraft part. A winglet there, and he's assisted by quite a lot of assistance systems. You see the information provisioning that's directly in the field of view, and you see a mobile manipulator that's like giving him or her the material that he or her needs. And that's basically the field of research we are in. I put this headline, research for the in-between, because of course we are working on automation issues as well. But as long as we do not have automation, especially in work systems like these, and site assembly with rather big parts and a lot of various tasks, we still need a lot of assistance systems. And as we work on assistance systems, we need the information about the environment, and we need the information about the scenes, the gestures, the postures, and that's why it absolutely makes sense to participate in this 3D track, actually. And that are basically our research fields. I already showed you, like human-robot interaction and digital assisted systems, and of course some issues that always come with that, like the safety, security, and privacy triad. And the more we talk about assistance systems in manufacturing and everywhere else, I think the more we have to talk about workplace-based learning, especially if automation keeps on increasing. And that's it. And therefore we need some methods and models, and usually we work in our pilot factory in Vienna with our students and project partners, and we set up demonstrators and do teaching like you see here. The last pre-corona lecture on assistance systems in production, where we had like bright students producing great demonstrators on tasks that can be shared for humans and robots, like putting shirts on hangers, stamping, and so on. But as you know, we've got Corona, and so we have to rather look at virtual settings. And as Markus Hennecke already pointed out, we've got a little open source robot programming environment that we actually set up within a project that it's still running with a lot of bright partners, the Uranium Research, the Grand Garage, a large makerspace in Linz, and the RIC, the Regional Innovation Center in Gunskirchen. And there we set up everything you need in order to run cobots, so collaborative robots, as laypersons, so as non-experts. And we try to bring these kind of cobots as tools into industrial and industrial-like environments. And if you are a layperson, you need some new tools in order to come with new use cases. And that's where the idea of this assembly simulator was born. And actually, my dear colleague Tudor Ionescu has created this little software, which is, as far as I'm concerned, very, very neat, as it's pretty much intuitive to use. As you will see, if you work with it, all the code is free. You've got a large GitHub repository, and if you program some tasks to the cobot, you even might already create the task for a real cobot. So that's done automatically, at least for the universal robots. And If you are interested in the idea to make assembly C, please join the hackathon on 3D, which will be hosted by Infineon and my dear colleague David Kostolani. And if you're more interested in all the stuff, there's a nice publication written by Tudor on assembly, or just look at the webpage assembly.comemac.at. It's still work in progress. It's still an alpha version. That's why we are so happy to develop it together with you within that hackathon. So that's the person you'll see, especially it's David, who is on the left bottom corner, and the other two persons is me, and this is Tudor, the mastermind behind assembly. So I wish you all the best for the hackathon, for all the tracks, but of course, especially for the 3D track. And thanks to everybody to invite us to join with our assembly tool to this very, very nice endeavor.
All right. Thank you very much, Markus Hennecke and Sebastian Schlund, for your introduction of the hackathon challenge that you're responsible for, namely 3D. Next up, we have Biosensing with Ronald Sterz. He is professor for mechatronics and electrical engineering at the Management Center in Innsbruck. He is much, much more than that, but he's going to tell you something about it in the next few minutes. So the stage is yours, Ronald, whenever you're ready.
Thank you for the introduction. Hello to everybody. I have not prepared a presentation, as I wanted to show you some pieces of hardware which all the teams which have signed up for the hackathon should have received by now. So the question which we had in mind was, as Infineon has now the Cypress portfolio in-house, we have been thinking what is the what are the USBs of the Cypress controllers. And on one hand side, it's quite obvious that the PSOCs have those integrated analogous functions, which which gives you the possibility to design analog circuits like you would do this on a breadboard, for example, if you would have to set up your circuitry. And therefore, you have been equipped with with one of those boards. I'm just struggling with the virtual background. This is a board based on the Cypress PSOC 5LP, which offers this previously mentioned analogous functions. So what possibilities do we have in biosensing given by some sensors out of the Infineon portfolio? For example, there are the pressure sensors around which can be connected via I2C connection or SPI to the controller, and you can gain some data. What this has to do with biosensing, this is what we wanted to turn around in let's say a flipped classroom approach. We are very eager to see and hear about your ideas, what you would like to do with a pressure sensor, for example. Is there a possibility, once again struggling with the background, we all know those nice masks. Is there a possibility to integrate this and to get some biosensing data out of this in some manufacturing area where you may need to wear those masks as well, not only like we have this in our normal lives today. On the other hand side, you have been equipped with a lot of different electrodes, like they are used for ECG or EEG or EMG applications. So the only thing you need is an instrumentation amplifier to get a first impression of a data which is produced by the human body, which then you can process further on the microcontroller, or eventually, if you think about the second board that you have received, that's the blue one, this offers you one of the other USBs of Cypress. This is all the wireless functionality. So you eventually may create, yeah, it's not much to see, sorry, and Android application out of it, which is able to show all this data you have acquired. For this purpose, we can provide you with a basic framework and a demo code which you can modify according your needs. And furthermore, due to the analog functions, you also may step into measuring capacitances, for example, given by the CapSense functionality. So this is just another board, but this shows those capacitive sliders. So in principle, this system also can be used to measure skin impedance. Once again, with the electrodes that you have been supplied with. So this is the setup that we are offering for the moment. And as mentioned previously, we are eager to hear about your ideas and approaches towards biosensing. Thank you very much.
All right, Ronald, thank you very much for your introduction and for your support at the Infineon Hackathon. Last but not least, we are going to have circuit design with Norbert Imlich. He is director for online marketing engineering at Infineon, and Bashar Sakar. He's application engineer at Infineon. And so, gentlemen, whenever you're ready, the stage is yours.
Thank you very much to the studio. Welcome to this session, Circuit Design. Really very much appreciate. And also together with Ronald, I mean, he just showed you this universe of circuits and boards. And since we cannot work on a physical level today together, we will work over the web together. And that's our topic, circuit design. You see here Infineon Designer, it's just one link away. And I would like to give you a short overview how you can make and take advantage of this infrastructure. So my name is Norbert Imlich. I'm working here in Munich. So it's not night, it's very shiny and sunny, but for the contrast, I took the night picture of Campion. If you're around, please visit us here. It's an open campus. So also for these 3 days, Bashar and I will take care of you. Don't hesitate anytime, day or night, to contact us if you get stuck. And yes, to not get stuck, we start with the vision. And the Infineon vision is to be the link between the real and the digital world. And that's not enough. To make this, to realize this vision, we need a lot of circuit. And designers all around the planet help us in designing those circuits, which make life easier, safer, and greener. And in this hackathon, we are together with you. You committed to submit a project within a very short time, only 2 or 3 days, to have a very innovative topic behind it, and partner. What is a system? And the system is here at the center, serving some application. You know, Infineon is very famous for automotive application, going to consumer, industrial, and of course also IoT here. And a system consists of both hardware and software. And with the Cypress acquisition, we really brought our software ecosystem to the next level, to also connect our system to the digital world, which is the cloud. And for every of these domains, we already heard from Marcus and Sebastian about sensors. Also, sound systems are sensors. Of course, the compute engine, which is based on microcontrollers, and actuation, where Infineon is really number one. We actuate all motors in every car, in every industrial setup. No factory is running without our motor control systems. In the end, it's not enough. We need safety and security who really shields all these activities, and that when it comes to circuit challenge. So how can your circuit now be easy to design, safe, green, and connected? That's our vision, to make the system here, starting from the sensor for the power transfer, and then also the connection to the cloud in one nutshell. And you have different challenges when you design such circuits. Of course, green means high efficiency. The system needs to be not overheating, which is taking care of the thermal design. On the other hand, electrical design, to see the signals. Is my design stable, or does my software run without errors? And this software design is topic together with the hardware design, electrical design in our track. So what is it now all about? You know, digital twin will offer you the possibility to simulate a circuit on a virtual system before you have the real hardware. And yeah, I can also try to show you real hardware. Now I disappear. I cannot send this to you, but I can send you a link. And this link I just showed you at the introduction. This is the circuit designer, which now combines everything. You have an IDE. You need hardware, which is microcontroller. You will write and build application code in a hex file, in the ELF file, and this can now be virtually downloaded or uploaded to the cloud before you download it to the target here on the real hardware. Why should you co-simulate microcontroller? And this is now we focusing on the XMC platform with SPICE. The first thing, you want to be fast. You now have only 3 days to make your project run. It's much easier to work on a virtual system. Second, if you use high voltages, it can be very dangerous. And in former days, I had curly hairs, but that is now over. So take no risk and virtually design your system first. And in the end, it's cost and security which make you take advantage if you use the virtual system. So the old environment was using Dave now, and that's really very cool. We have a new environment called Modus Toolbox, supporting for the first time XMC 1400 platform, and we would like you to take advantage of this new ecosystem and program the microcontroller together with your analog circuitry. And that's the platform you will use, the XMC family 1400. And this is how the ecosystems look like. As we said, we have an IDE environment. Please download it here, write your code, upload your simulation, ELF file, images, and then start the simulator. And I come back now. Really, this is the real. You can check the performance. You can step through your code and see the whole software you built without having the hardware. And that's what we would like to invite you to use. And yes, with this, I wish you a good start. I think we have time later to go to the details, and I would like to hand back to Raphael to the studio. Thank you.
All right, Ronald, thank you very much for your introduction and for your support at the Virtual Infineon Hackathon. This concludes our introduction round for all the tracks and challenges that are embedded into the Virtual Infineon Hackathon powered by EIT Manufacturing. Last thing on our agenda before we officially get into hacking with all our participants is an overview of what will be coming up next in the next few hours and next few days. You surely don't want to miss our participant interviews tomorrow at 5 p.m. as well as interviews on Wednesday at 5 p.m. to have a look at how our participants have been doing during the hackathon. And for more insights, join our official closing award ceremony on Wednesday at 5:30 p.m. And if you are interested in further details, join us at www.infineon.com/hackathon.
Yeah, without further ado, in the name of Infineon, I want to thank our partners that supported us in this journey for enabling this hackathon to be possible. This is first up, of course, EIT Manufacturing, who were by our side from the first day organizing this event. This is namely Vienna Up 2021, the MCI Innsbruck, the Industry Meets Makers, the Science Park Graz, the Technical University of Vienna, and PMD, and many, many more. You all know who you are. I want to say a big thank you to the organizing team and the track owners for their support during the session today and during their help in the next few hours of this hackathon. And of course, I want to thank all the participants for being part of the hackathon. You are the true pioneers of this event, so thank you very much for participating and being with us. And yeah, this concludes, I think, our kickoff of the virtual hackathon powered by EIT Manufacturing. Thank you very much for having us, and goodbye, see you soon.